okay? Yeah, we don't touch anybody else in this class. All right, let's see. Get some winners today. Jaden, what did you notice? Well, don't give up right now, Jaden. Let's look through it. Jaden, check it out. Look at these two parents. See those two parents? They're both blue. That means they have the trait. Jaden, what do you notice about their child right there? It's a square. What does that mean? Anybody know? If it's a square in a pedigree, try again. It's a man. Yeah, it's a man if it's a square. And if it's not filled in, it means that that person, in this case, a man or a male, does not have the trait. So this child does not have the trait, even though their parents have it. Now, does that seem kind of counterintuitive? It does. We think kids should look like the parents, but that's what's possible with with a dominant trait. Yes. Not for this trait. Like if this trait is, say, widow's peak or attached earlobe or hair. I'm sorry, hair. Some of us have a little bit of hair on the knuckles here. This child would not have that trait. So for number one, you need to write something to the effect of both parents have trait, child does not. And like I said, that seems like it doesn't make sense. But let me show you why it does. We're looking at an autosomal dominant trait. Oh, no eating in class, Caden. So why don't you zip that up. Also make sure your phones are all zipped up and put away too. If you have a case where if it's dominant and both parents have it and the kids don't, that means the parents are both heterozygous, which means they have one of each. They show the trait, but they have one of those recessive traits there. So what can happen, I need you to draw this Punnett square, and this would be what it would look like. Go ahead and fill that out for me real quick. Draw that Punnett square, and then fill it out. Yeah, the box at the bottom. Go ahead and put the letters in there that need to be in there. Just find any spot. Maybe looks like you have a lot of space on Monday. Okay. Well, until that happens, I would say just draw it, right? Better safe than sorry. So what goes in those boxes? We practiced this yesterday or Monday. Yeah, so that first one would be AA, right? Capital A, capital A. This next one would be capital A, lowercase, capital A, lowercase. And see that lowercase a? That's what that kid would have. So, now that you see the genetics, the Punnett square, now it might kind of make sense to you. Oh, that could happen. You could have the child look different from the parent because that recessive allele could be hiding out, and in this case, there's no dominant allele to show the trait. Caden, so remember that all that needs to be put away forever in this class. That means the rest of the class. No eating. Now, let's look at for the recessive trait, because it looks a little different. Okay, Leonardo, what did you notice for this recessive pairing? Parents versus kids. They what? Yeah, they got their parents' trait. Do all of them have the parents' trait? Are they all filled in? They are, right? So in this case, what you can have for recessive traits, if both parents have that trait, if it's recessive, all their kids are going to have it. Okay, so write that down. And I'll show you why in a second. Or could you show me why with the Punnett square, why that's true? Ivan? If both parents have trait, all children will too. Now, how could we show that with a Punnett square? Remember, if they are showing the trait, it means they have little a's. So what would the Punnett square look like? What letters would you put on the top and on the side? How many letters are there to choose from? There's one. There's only one letter. So the only thing that could possibly be in here are A's. So there's no possibility. Oh, Fred, we got to stay inside. Okay, so if you'd have that, just go to the back of the class. But we can't go outside. Yeah. No, there's no big A to get in there, so no matter how many kids they have, they're just going to have all little a's. Okay? Now, another thing that's interesting that might seem counterintuitive, what do we see with these? Do these parents have the trait? No, but what do we have? A kid that has the trait. So how does that work? No, ha 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 ha. That's what we might think, right? But genetics are tricky, right? Kids don't look just... Do kids look just like the parents? Sometimes they look really similar. Sometimes not as similar. Can siblings look different from each other? Sometimes they look really similar. Sometimes they look really different. Can they have different hair color? Different skin color? Different eye color? Yes. So genetics is really tricky. Oh, Francisco, let's take all the headphones off. Okay. Yes, but for autosomal recessive, traits can skip generations. Write that down. Skip generations. So it can, as we see this parent here, they don't have it, but in the next generation, they have it. Okay, so there's generation skipping. That's because you could have both parents be heterozygous, right? They have the big A and the small a. You have to have both little a's to have the disease or the trait. Could this A match up with this A in the child? Yeah. So that's what happened in this case. It looks very similar to right here. Oops. That would be that child right there. All right. So the moral of the story is, what is the moral? What do you think the moral of the story is? The moral of the story, the overall learning from this little example. When we look at genetics, what do we see? We can see differences where we might not expect to see them. Okay, yes? Sometimes they can be similar traits as the parents, or sometimes it can be different traits from the parents, right? Normally we think they're going to have all the same traits, but we know that's not true, right? Do you look exactly like your parents? No. There's differences, okay? You don't look exactly like your siblings either. You might look similar, or you might not look as similar. But the moral of the story is things can turn out differently than we might anticipate, okay? But we can explain it, okay? Just because things seem different doesn't mean it's not happening or there's not a reasoning behind it, okay? We can study and figure out what's going on there. Okay, so today, this is the plan. I'm going to give you some time to finish up the vocabulary activity that you started yesterday. Sure thing. So, if you need another one, who was not here Monday? Who definitely needs one? Yeah. You lost it. Okay, anybody else lose this paper? Or needs one somehow, some way? There you go. Ivan, you need one? Okay. Oh, dang, you guys. Whoa. There you go. Trishawn. There we go. So I'm going to give you. So first things first, finish this assignment. Finish your flashcards, your digital activity. Oh, everybody quiet and listen up, please. Eyes up here. Almost done. Finish up this. Then I need you to work on the study guide. We're going to have a test Friday. I want you to get ready for that. So like the first question on the test, the study guide. You can use the notes you took for the videos you learned from in class, or you can just do a Google search. Like the first question is, what are chromosomes made out of? Could you Google search that? Yes. And then you can find out, oh, not yet, the two major molecules they're made out of. All right? With about 30 minutes left, 25 minutes left, we are then going to work on the Walking with Caveman video again. So if you have those notes handy, keep those handy because we'll be adding more to those and turning those in today. So to recap, finish this. When you're done, turn it in up here. You can staple like this dude. I think a lot of you are doing the flashcards. To staple the flashcards right to here. If you do it electronically, you don't have to turn anything in. You just turn it right in on Canvas. There's scissors back there. There's paper right there. Then I'm thinking probably, I think one student last period finished the whole study guide. So, but not many people have been finishing it. But maybe you'll finish it. So try to finish it if you can. And then we'll move on to Walking with Caveman. All right? Okay, any questions? All right. If you're working by yourself, you can wear your headphones. Or if you're working together, just leave them out because you need to talk to each other. You need to collaborate. Okay? And if you want to work, if you're working together, you work at a station. You can't work at a station in the back. All right, let's go. Let's get this done.